This is Mr. Liao, and it's time for section 6.2 for AP Statistics, Probability Rules. Today, our objectives are to state the probability rules, the first 5 at least, define complement, disjoint events, which is another word for mutually exclusive events, independence, and how to use the proper notation when writing probability. Also, we're going to use Venn diagrams to describe probability models. So if you need to stop at any point to go back something, we'll go ahead and do that. This is a video. I won't be offended. Alright, so I want to highlight sample space. We talked about this last week. When actually writing the sample space for a random phenomenon, you need to use set notation. So for example, if you were rolling a die, the set would be S equals 1, 2, 3, 4, 5, and 6. So just be really careful. It's not that big of a deal to me, but if you wanted to be formally correct, that's what you would need to do. Alright, so as a review, probability of any outcome of a chance process or random phenomenon is the proportion of times the outcome would occur in a very long series of repetitions. So you would just keep on doing the event, and whatever the proportion of times a certain event occurs, that's going to be the probability. So for probability rules, we need to learn how to write notation in probability. So this PA thing is going to be the first thing you're going to want to notice, because this is how we write the probability of event A. If it was PB, or probability of event B, we would write PB. Okay, so these are probability rules. And remember, all these rules are intuitively true facts about long-run proportions. Anything can happen in a small sample size, but in the long run, over many, many trials, these rules are going to be true. So first rule, the probability has to be a number between 0 and 1. Well, this seems very obvious. An event with a probability of 0.5 occurs in half the trials in the long run. Remember, the probability cannot be less than 0. It cannot be more than 1. So please do not make that mistake. It happens all the time. Please, 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 please do not write a probability that is less than 0 or more than 1. Rule 2. All possible outcomes together must have a probability of 1. This S refers to the sample space of all the possible outcomes in an event. So the probability that one of those outcomes happens has to be by nature 1, by definition 1. So if S is the sample size in a probability model, then the sum of probabilities for all outcomes must be exactly 1. Rule 3. This introduces the idea of a complement. A complement refers to the opposite of the event itself. So the probability of a complement is 1 minus the probability of the event happening. So this notation, A sub C, refers to a complement. And this plus this have to equal 1, because this refers to the probability of A happening, and this refers to the probability of A not happening. So those are the only two possible outcomes. Together, the probability has to equal 1. Here's rule 3. The probability that an event does not occur is 1 minus the probability that the event does occur. So for example, if an event occurs in 60% of the trials, then it fails to occur in the other 40%. So that's the idea of a complement. Sometimes it'll help you with a problem to not use the probability that an event happens, but the probability that the event does not happen, and use that in your calculations. So this is the idea of a complement. Notice complement is spelled C-O-M-P-L-E-M-E-N-T with an E there. This is not something nice you say to somebody. This is something that completes something else. Alright, rule 4 is the addition rule for mutually exclusive or disjoint events. If A and B are disjoint or mutually exclusive events, then P of A or B equals P of A plus P of B. When two events have no outcome in common, the events are mutually exclusive or disjoint. So disjoint is the opposite of joint. The two events cannot happen at the same time. So for example, you cannot be both at Milpitas High School and simultaneously at the Great Mall. So those are two mutually exclusive events. You cannot both be in San Jose and at the same time be in San Francisco. You cannot be both a freshman and a sophomore at the same time. Those are two mutually exclusive events. They are disjoint events. So if that's the case, the probability of those two events, one of those two events happening, A or B, is equal to the probability that one event happens plus the probability that another event happens. So, if one event occurs in 40% of all trials, a different event occurs in 25% of all trials, and the two can never occur together, then one or the other occurs in 65% of all trials, because 40% plus 25% equals 65%. So when two events are mutually exclusive, you can add their probabilities together individually to get the probability that one or both happen. Well, they both can't happen, so just at least one happens. So we're going to use Venn diagrams to illustrate the sample space of a chance process. We will also be using set notation to express probabilities, so you'll need to learn the symbols and what they mean. So the first concept is the idea of a union of two events. And you see that little round U thing, that basically means union. So you would say this as A union B. This is the set of all outcomes in either A or B. So when you see this symbol, this round U thing, this is the equivalent of OR. So when you see A or B, that's this symbol. Now A or B means could be A, it could be in B, or it could be in both. So this isn't one of those A or B, only one. A or B by probability definitions could mean both. So it really means A and or B. So the union is the outcomes either in A or B or both. So the probability of the union of A and B is equal to the probability of A plus the probability of B minus the probability that both happen. Because if you have to subtract the probability that both happen, otherwise you are double counting this section in the middle. Okay? So don't worry about this formula yet. We're going to get to it in a few minutes, but that's basically what the union refers to. The other set notation concept is the idea of an intersection. This upside down round U kind of looks like an N. So, whoops, over here, that means the intersection of A and B. This is a set of all outcomes in both events A and B. So notice in a Venn diagram, it is the overlap of the two circles. So this might be ninth graders, and so for example, this might be ninth graders, and this might be males. So this section would be all the freshmen that happen to be male. Okay? So this would be over here, the males that aren't freshmen, and over here would be the ninth graders that aren't male. So this is the intersection, the people or the group that fit both A and B. And if and only if events are independent, the probability of both A and B happening is the probability of A times the probability of B. And this is true for independent events mathematically. So if you're not sure if events are independent, if you're given the probability of both events happening and the probability of them individually happening, if the probability of each event happening multiplied by the other event happening equals the probability of both, then you have independent events. We'll talk more about independence in a little bit. The empty set is the event with no outcomes in it. So for example, maybe this is the group of freshmen, and this is the group of sophomores. There are no students that are in both groups. So that would represent the empty set, the event that with no outcomes in it. There are no students that are both sophomores and simultaneously freshmen. So, disjoint and mutually exclusive events. The events A and B are mutually exclusive or disjoint because they do not overlap. They have no outcomes in common. So, ninth graders and 10th graders are mutually exclusive. That would be another example. People that are in Math 1 and Math 3 probably are not the same group of students. Okay, people that are in English 1 and English 4, probably no overlap. They have no outcomes in common. You cannot, again, be in the L building and in the H building at the same time. So those are mutually exclusive events. And this is going to be often confused with the idea of independence. Think exclusive, think a relationship. If you are exclusive, you're only dating one person and nobody else. So that's the same thing. You can only be in one of these circles. You cannot be in both. If you're in A, you cannot be in B. If you're in B, you cannot be in A. So these are examples of mutually exclusive events. If you are in one, you cannot be in the other. If one is true, the other cannot be true. It is exclusive to one or the other. So the rule with the complement, the intersection of the two an event and its complement has to be 0. And this makes sense because the probability of you being a freshman and the probability of you not being a freshman is 0. You cannot be both a freshman and not a freshman at the same time. Likewise, if you combine the probabilities, they have to equal the sample space, or 1. So the probability of being a freshman and the probability of not being a freshman, those two probabilities added together have to equal 1, because those include all the possible outcomes of a random chance event. So let's take a look at some coin flips. 4 coins are flipped. What is the probability that at least one of the coins is heads? Well, this will be the complement of having all 4 coins as tails. So instead of thinking at least one coin heads, which means you got to add the probability of getting 1 heads plus the probability of getting 2 heads plus 3 heads plus 4 heads, just think of it this way. It's the opposite of getting at least 1 heads is getting all 4 coins as tails. So the probability of getting at least 1 head is equal to 1 minus the probability of getting 4 tails. Now, how do you get 4 tails? Well, you need 1/2 to get the first tail, times 1/2 to get the second, times 1/2 to get the third, times 1/2 to get the fourth. So that combined is equal to 1/16. So 1 minus 1/16 is 0.938. 15/16 is the probability of getting at least 1 head. Let's take a look at this example, distance learning. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking distance learning courses for credit and record the student's age. Here's the probability model. So you have the different age groups, 18 to 23, 24 to 29, 30 to 39, and 40 or over, and the probability of picking a student in each group, 0.57, 0.17, 0.14, and 0.12. So the first question is, show that this is a legitimate probability model. When the question asks this, it is asking you to verify that rules 1 and 2 are satisfied. So rule 1 is that every individual probability has to be between 0 and 1. And this is true. 0.12, 0.14, 0.17, 0.57 are all between 0 and 1. Then all the probabilities together in the sample space have to equal 1. So if you add a 0.57, 0.17 plus 0.14 plus 0.12, they necessarily have to equal 1. So this is indeed a legitimate probability model. All the probabilities are between 0 and 1, and the sum of the probabilities in the sample space equal 1. B, find the probability that the chosen student is not in the traditional college age group, which means the student is not 18 to 23 years old. So the way to think of it is you can either add up all the groups that are not 18 to 23, or you can think of it as subtracting the probability that you do pick someone from 18 to 23 and subtracting that from 1. So you can either do 0.17 plus 0.14 plus 0.12, or you can do 1 minus 0.57. In either case, your probability of picking a student that's not in the traditional age group is 0.43. So 43%. So the probabilities in a finite sample space. If you assign a probability to each individual outcome, they have to be between 0 and 1, and they have to add up to 1. So a finite sample space basically means you have a countable number of possible outcomes. The probability of any event is the sum of the probabilities of the outcomes making up the event. And we saw this in the previous example when we looked at the complement. Instead of looking at the people that were not under 18 to 23 or under 18 to 23, we would add up the people that are in each of the 3 age groups older than 18 to 23 to find the total probability. So for example, C, find the probability that the chosen student is age 30 or over. So we can look at this probability here, 0.14, and add it to the probability of being 40 and over, which is 0.12. So 0.14 plus 0.12 is 0.26. Equally likely outcomes. If a random phenomenon has k possible outcomes that are all equally likely, then each individual outcome has a probability of 1 over k. And the probability of A is equal to the count of outcomes in A over the total number of outcomes in S. Now this looks really complicated, but basically what you have here is a situation where you have k total outcomes and each probability has the same chance of happening. So if you were rolling a die, k would be 6. The probability of getting each individual roll is 1 over 6 or 1 over k. And then to find the probability of event, you will take how many ways you can satisfy that quality. So let's say I want to find the probability of rolling an odd number. So I could find the probability of rolling a 1 plus the probability of rolling a 3 plus the probability of rolling a 5, all divided by 6. 6 being the total number of outcomes in S, and the probability of 1 plus 3 plus 5 are the possible outcomes of rolling a die that would satisfy my requirement of having an odd number. So this would come out to 3 over 6, because there are 3 ways to get odd numbers. So the probability is 1/2. So that's the simplified version of it. I think this is more intuitive, and the idea of having a formula makes things even more complicated. So let's take a look at a deck of cards. Remember, a deck of cards is 52 cards, 4 suits, 13 cards in each suit. A card is chosen from a normal deck of cards. What is the probability of choosing either a king or a queen? So what you want to think about is how many ways are there to draw a king and how many ways are there to draw a queen? Well, there are 4 kings in the deck and there are 4 queens. So the probability of drawing a king is 4 out of 52. The probability of drawing a queen is also 4 out of 52. So combined, add up the probabilities, you get 8 out of 52, or 2 out of 13, or 0.154. You can add the probabilities here because these are mutually exclusive events. A card cannot simultaneously be a king and a queen. So you can add up the individual probabilities because the individual events are discrete. They're separate. They won't both happen at the same time. Mutually exclusive events. Let's take a look at this next example. B. A card is chosen from a normal deck. What's the probability of choosing a face card or 2? And remember, a face card is a king, queen, or jack, not an ace, despite what some students say. So the probability of getting a face card or 2 is the probability of getting a king, plus the probability of getting a queen, plus the probability of getting a jack, plus the probability of getting a 2. Now you'll notice there are 4 cards of each rank in a deck of cards, and they are all mutually exclusive. You cannot get both a king and a 2 with a single card. So what we can do is add up the probabilities, 1/13 plus 1/13 plus 1/13 plus 1/13, or 4/13, which comes out to 0.308. Let's take a look at this cholesterol example. To choose an American adult at random, define 2 events. So event A is a person having a cholesterol level of 240 milligrams per deciliter or above, which is considered high cholesterol, and a person having a cholesterol level between 200 and 239 being borderline high. And the probability of someone having high cholesterol is 0.16, and the probability of picking an American adult with borderline high cholesterol is 0.29. So we're now going to answer some of these questions. Explain why events A and B are mutually exclusive. Then answer number 2. Say in plain language what event A or B really is. And if C is the event that the person chosen has normal cholesterol, which is below 200, what is the probability of C? So stop the video, take a couple minutes to answer these questions, and resume the video when you're ready. So events A, why are they mutually exclusive? Well, you cannot have a cholesterol level that's simultaneously over 240 and also between 200 and 239. It's either 240 or up, or between 200 and 239 or something else, but they cannot satisfy both. So events A and B are mutually exclusive because they both cannot take place at the same time. What A or B really means? A or B means it's the set of all people that have cholesterol over 240 or between 200 or 239, which really means it's the set of all people that have cholesterol 200 and up. To find the probability of A or B, remember these are mutually exclusive events, so we can add up the probabilities of the individual events together. So the probability of A plus B is 0.16 plus 0.29 or 0.45. The probability of picking someone with a cholesterol level of 200 or up is 0.45. Event C is choosing a person with normal cholesterol below 200. What is the probability of picking someone with this cholesterol level? So C is the complement of A and B. If A and B is picking a person with cholesterol 200 and up, C is the opposite of that. It is everybody else, people with cholesterol below 200. So to find the complement of A and B, you add A or B together and you subtract it from 1. So the probability of A or B happening from part 2 is 0.45. So the probability of picking someone 200 or below 200 in cholesterol is 1 minus 0.45 or 0.55. Okay, you could have also figured out that whatever's left from the first 2 probabilities has to be the people that are under 200. So that's basically the informal way of doing the same calculation. We're going to take a break there, and we're going to have you start the next video on a separate video because I don't want to overload my iPad.